Hello and welcome to FlyByWire Simulations in the Hangar episode 7. Welcome back. I'm Kiwi, as usual, your host, and I'm joined alongside some of the developers once again to showcase the FlyByWire projects with the upcoming features. After this episode, we'll be running a Q&A in our Discord in the Outside the Hangar stage channel. And that'll be straight after this stream. So make sure you go down to our description on this video and join our Discord through the links below. Right now, however, I'm joined alongside, as I said, some developers, and as you can see on screen, they are Blueberry King, Boris, Holland, Kevin, myself, and Sid. And they will be showing you some of the things that they've been working on over the past few months on the A32NX and showing the progress that we've made. First, however, I want to start off by basically saying a massive congratulations to the project, to the team, to everyone who's been involved over the past 12 months. It is officially 1 year of FlyByWire Simulations and just over 1 year of the A32NX overall. So over the past 12 months, we've seen a fantastic response to the aircraft, and we've been overwhelmed by the support from developing to financially and simply by people sharing their appreciation online and in our Discord. And for that, we thank you for being part of our journey, and we look forward to having you alongside us for the next year, where we hope to bring you even more amazing features to the aircraft and bringing you such a more immersive experience in the simulator. To put into perspective the past 12 months and to give you an idea of the scale that we're working on at the moment with the A32NX, we've got some statistics that we've been collecting since November the 5th last year. And I'm going to share some of them now for you. So as you can see on screen, we've had over 2 million downloads of the aircraft itself. So that's full downloads of the aircraft without updating. And that includes both GitHub and on the installer, so prior to when we had the installer introduced. We, in the past 7 days, have had over 4,000 downloads for the experimental branch, and that is obviously expected to rise substantially, especially when we start to add even more features to the experimental and really focus the production there. Overall, the downloads have equated to 600 or over 600 terabytes of data, which is an absolutely ridiculous number. And obviously through the Open Collective, we've been able to support that. So we thank everyone who's donated there, because you've really helped us deliver this aircraft to as many people as possible who may not have been able to see our GitHub, but have seen the installer and been able to download that. Overall, since November last year, with the statistics that we have been able to obtain, the aircraft has been flown for the equivalent of 450 plus years in total, which is absolutely mind-blowing. So thank you very much. And we've seen we've seen incredible amount of people using the aircraft, seeing them on Facebook, Twitter, other socials, and then our Discord, and it's been a real thrill to see that many people using the product that we've been producing. So thank you. So that's a little bit about the scale that we're working on and how many people are actually using the product itself. But obviously, we've got to keep developing this aircraft to enable you to keep enjoying getting to have a more realistic experience. And over time, that's going to be the case because we have set goals which we want to reach to ensure that you have a more immersive experience the longer you use it. And this includes adding various features. So if we look at our goals, which will be on screen very shortly, you can see we have 3 separate goals that we are aiming to achieve. So the first one is to have normal operations, which is 95. We want 95% or more of the normal operations on the A32NX to be modelled. So this includes the complete FMS and the very much requested LNAV and VNAV, which is being worked on currently. And you can obviously experience some of that at the moment. Realistic avionics and sounds, which you'll find out a little bit more information from Boris a little bit later on, and the rudimentary maintenance systems, which we'll have more information on in the future. And this is, in a short outline, what we want for normal operations. However, not everything goes to plan, and sometimes issues in real life can occur, and we want to simulate that in the A32NX as well. So we want to introduce abnormal operations, failures, advanced maintenance systems, individual part simulation. And this will really bring a true immersive experience of understanding the mechanics of the aircraft and what the aircraft can withstand. So we'll have simulation of the circuit breakers, hydraulic system parts, advanced braking of the aircraft and servicing that you may have to do, as well as stress-based failures. Flight is naturally a stressful thing for aircraft, especially heavy aircraft like the A320, and we want to simulate that in Microsoft Flight Simulator to give you a true experience of what a pilot would have to think about when they're planning their flights and planning on approach, etc. Finally, once we've achieved all this, we want to start working on variants for the A320. So, as you know, at the moment, we are currently developing on the A320neo, and we want to eventually look into other variants of the aircraft subject to the data that we can find. And this will be different variants of engines and different variants of the A320 itself. And so we look forward to reaching that goal in the future, subject to the normal and abnormal operations being achieved, which I'm sure with the support of you, the community, and our experienced developers, we can reach that. We just need, obviously, some time. So that is a little bit about the year that we've had and what we are looking forward to over the next few years of the development in the A32NX alongside the A380X, which we'll have a little bit more information about later on in the episodes. Stay tuned for more information and some very much wanted content. So, without further ado, I'm going to go ahead and pass you on over to Sid to talk a little bit about the weights and balances of the A32NX.
Thank you, Kiwi, for that wonderful introduction. It's been one glorious year of FlyByWire, and I must say we have pulled off a lot of things that we may not have expected in this particular year. So moving on, we have a couple of development updates and previews from the developers on board the FlyByWire team itself. And to start off with, I am going to introduce you to the first update that we have here. Now, this updated weights and balances that we're going to talk about, it's not currently in the development or the experimental version, but it's been worked on with quite some force. It's going to be there soon. And to explain more about this, I'm just going to quickly bring up a layout. As you can see on the current screen, we have the distribution of seats that you can find on the current A32NX, both the development and the experimental version. By the first look, you might find it a little inaccurate in the sense we have 102 seats in the front section, and the aft section has about 72 seats. So the total is about 174. But this sort of a distribution leads to a little imbalance when you're loading your passengers as well as the baggage that they carry. To solve this, we have had wonderful contributors, Mr. Ghosh and Vinicius, who worked on a pull request that introduces some massive changes. As you can see here, we've got 4 different sections. We have 36, 42, and 48 section seats in the updated model, which is coming really soon. Apart from this, we have also modified the stations where you load payloads. For example, we have forward baggage, container, and we have 3 specified sections for the aft luggage that has the aft container, aft baggage, and aft bulk loose. So we have specified sections where you can carry your luggage. You have containers which carry goods around the cities, and we also have aft bulk and loose cabin, which is more of a pressurized cabin where you can carry livestock, animals, pets, and so on. So this detailed update is also an indication of what we are aiming for as a team, looking forward to some improvements in the existing flight models and the amount of detail that we're looking forward to. So that was about it for the updated weights and balances. Without wasting any much time, let's proceed to the next update. Now, this one is probably the most exciting part of the A32NX, which most of you would be already enjoying in the simulator. So, to get started on that, I want to hand off the mic to Boris. Now, talking about Boris, you guys must have guessed what we are going to look at, and that is sounds. So, Boris, over to you.
Hello, and thank you, Sid. Over the past few months, we have been improving the sounds, and now we have completely replaced the entire sound set with fully custom ones, using real recordings and high-quality samples that we've taken from our engineers. Next up, we are also working on cabin ambience, with different passenger sounds and flight phases such as boarding and cruising, all of which will be dynamic. You will be able to select your airline from the EFB, which allows you to have announcements for different airlines, including different flight attendants and captains. You will also have a generic option in case the airline has not been added to the EFB yet. Then, lastly, we will have dynamic system sounds. As of now, our electrical system is dynamic for sounds, so each contactor makes a sound when transferring between generators or turning on the batteries. In the future, with our custom fuel system, we will have sounds for the fuel pumps running dry, which sounds higher pitched and more scratchy. No other A320 add-on has done that, so I'm very excited to implement that. Also, the hydraulic pumps will react to load, dropping the pitch when the pump is stressed. So you will be able to press the yellow electric pump push button on overhead with no engines running and hear the PTU work in the back of the cabin. With every pulse of the PTU, the pitch of the yellow electric pump sound will drop for a moment, then come back up. And yeah, that is it for sounds.
Well, thank you, Boris. That was a brief update, and I'm pretty sure everyone who flies the A32NX at the moment loves the sounds, and we've got some amazing feedback from the community. Moving on, we have another major system implementation that is partially in the A32NX already, and we've planned some more improvements over time. So to talk about this, I'm gonna pass on the microphone to Blueberry King.
Thank you very much, Sid, and a very warm welcome from my side as well to this special episode of In the Hangar after 1 year of development of this fantastic aircraft. I am very excited to be showing you some of the things that I've been working on ever since I joined the Fly-by-Wire development team. And this is starting with the bleed system. So this is something that I'm currently working on and that is not yet available in the experimental or the development version. But for those that might not be familiar, I will be giving you a brief overview of how the system works inside the aircraft. So the bleed system is a system of pipes and valves that bleed air from mostly the engines and the different compressor stages inside the engine to various places in the aircraft where it is needed. So this highly compressed air, which is taken in from the front of the engine and then compressed in order to turn the combustion cycle, is bled off, which is where it gets its name from, through some regulating pipes and heat exchangers to then carefully regulate it and provide it to different places inside of the aircraft. This bleed air has a couple of uses. Namely, it is used to pressurize the cabin and provide fresh air throughout the whole flight to the passengers. This is done through the system of the packs, which essentially take this still very hot air at around 200 degrees centigrade and filter it and cool it down and then provide it cleanly to the passengers. A different use that is also shown on the ECAM page of the bleed, one that some of you pilots might be very familiar with, is the APU bleed, which is used to turn the N2 turbine inside the engine, which is used to get the combustion cycle going once fuel is injected by the FADEC. There are various other consumers of the bleed air, such as the wing anti-ice system, where the very hot air is provided to the leading edges of the wing and the engine nacelles to heat up any ice that might have built up there. I want to talk a bit about our approach that we are taking with the design of the bleed system inside the H32NX, which is that we will be aiming for modeling as many of the components in the bleed system as accurately to the real world as possible, which is something we strive for all of the systems inside the A32NX, obviously. But what this means in the sense of the bleed system is that we will actually be modeling most of the valves and sort of pneumatic containers inside the aircraft, just like they would be in the real aircraft. And what this allows us to do, if we look at the vision that we have at FlyByWire, which is what Kiwi was talking about earlier, is that in the future, when we introduce failures to the aircraft, this will allow us to fail individual components, such as triggering a leak in a pipe or something. And this will pretty naturally lead to the cause of the correct ECAM warnings showing up to the pilots. So instead of actually triggering a specific ECAM warnings and then just taking the steps to mitigate this issue as a pilot, you might actually have to look through the different ECAM warnings coming up and then sort of trace back to where the issue actually might lie instead of just very simple issues. So this opens up a lot of possibilities in the future. As I said earlier, we are still working on the bleed system as of now, but we hope to be able to provide you with an early version of the bleed system sometime soon-ish. And I hope you are all very excited for it. And with this, I'm going to be passing it off to Holland for an overview of the new LNAV system.
Hello. So we at FlyByWire place a very big importance on the FMS, which is really the brain of the aircraft. During any flight, I mean every normal flight, you will have to use the FMS to plan your route and make the aircraft follow the route that you're planning to take. So it's really important that the systems work flawlessly, because if they don't, then you're going to notice, and it's going to be annoying if the flight doesn't go like you're planning it to go. So what we're really doing is creating an entirely custom FMS, which is going to be entirely based around the same architecture that is used in the real aircraft. This means that not only is there actually going to be the correct number of independent systems that are going to be simulated individually, but the software architecture inside those systems is also going to be exact. And not only that, the algorithms used to compute the path are also inspired by the real behavior. This means that when you input a certain route or load a certain procedure, you can be assured that we will draw and fly a path that's going to be exactly the same one that you'll find in the corresponding FMS revisions in real life. So I think we have a system diagram we can show on screen. So this is something that we've spent time thinking about and making sure is accurate. It's kind of an overview of how this system works at the low level. We start with a nav data backend. This sounds complicated, but it's basically just a database of procedures and waypoints. So when you load a departure or an arrival or an airway, well, this is where they are stored. We've worked with Synaptic Simulations to make a new library called MSFS Nav Data. And what this allows us to do is to independently operate on two different nav data backends. We first have a MSFS native system that loads the same nav data that you use every day in MSFS for every other aircraft. That doesn't have its own independent database. This works either if you use the default ARAC cycle from MSFS or if you install NaviGraph. We also have another option that allows you to connect to a server installed on your computer. And what this allows you to do is get past the limitations that are currently in place in the MSFS nav data systems. So no publish holds or some missing information about some procedures. This allows us to bypass that. So when we implement holding patterns, you will be able to load publish holds or grid mora or something like that. So data that really isn't present in MSFS. As MSFS adds those new capabilities, we'll update the MSFS system to make sure that everyone can enjoy a stock experience that's as good as possible. We then have the custom flight plan manager, which is the interface that allows modifying and sequencing of flight plan elements. So when you insert a procedure or delete a waypoint or add one, do a direct to, this is the part that really takes care of that. This is, of course, receiving commands from the MCDU, which is a computer you use to interact with the FMS. This also then goes into a next step, which we call flight plan stringing, where we generate a path in high-level terms of legs and transitions. So a leg is a path between two waypoints you will find on your MCDU flight plan page. And a transition is a path computed by the FMS in order to sequence correctly between those two. There's hundreds of combinations that are generated by the real-life FMS, and we'll reproduce every single one of them eventually. We're going to start with a really simple system like we have an experimental right now that covers 90% of cases. But as we go forward, you can expect way more precise construction of the path. This then goes into path generation, which constructs the guidance path and the visual path on the ND using arcs and lines. So it really breaks it down to simple elements that are strung together. This is then influenced and influences the predictions, so speed predictions, altitude predictions, and wind predictions. This then generates both the guidance commands to the autopilot system and also generates drawing on the ND. So this is how you get your path on the ND, and this is how your autopilot knows how to fly the plane. This system is really basic for now. The version you have in experimental only supports a few types of legs and transitions, but we're planning to support the whole thing, as I said earlier. So holding patterns, offset legs, procedure turns, pretty much everything there is in a real FMS, and you can expect this to be one of the most accurate, if not the most accurate LNAV systems to ever be put in a home flight simulator. I'll then pass this off now to Blueberry again, so we can look at the custom standby instrument.
Thank you very much, Holland, for this awesome insight into the upcoming LNAV system. I'm back again to talk about the reworked Integrated Standby Instrument System, or ISIS. This is a system that I worked on some time ago and is now already in the development version of the aircraft. This is more of a technical rewrite, or this is what it was supposed to be originally, which is that we plan to make one step towards this milestone of rewriting all of the displays in a framework called React, which has essentially two purposes for us, which is that it should be able to provide some more performance to the aircraft in the simulator, but also should make it more maintainable for us developers in case we ever need to add any features or fix any bugs in the future. Aside from this technicality, though, the ISIS has also gotten a couple of feature upgrades, which is that we know pilots all across the globe use the A32NX to fly routes wherever they wish to. So the ISIS now also features a metric altimeter reading showing you your current altitude in meters, and not just the foot readout that you have on your PFD by default. We also show the QNH, the barometric pressure setting in hectopascals and inches of mercury. And some of you might be excited to know that you're finally able to click the barometric knob to quickly convert to a standard pressure setting. Furthermore, not a very commonly used feature on the A320 in general, but we now fully feature the box page, which you can see on the very right here in the screenshots. The box page allows you to set certain box or sort of markers on the speed and altitude tape. So one might use this to set takeoff speeds such as V1, V2, and VR on it, in case you need in the case of a dual PFD failure, for example. However, it is interesting to know that this is not recommended or advised against by most airlines for a very specific reason, which is that, say you do not have a PFD failure during takeoff, but rather in cruise, then these speed or altitude box you might have set for takeoff could be quite confusing if you were looking at them during approach and landing. So this is some of the things that we feature in the integrated standby instrument system now, and you can try this out in the development version and experimental, I believe. And I know that the ISIS might not be the screen that you're going to be looking at the most, but I hope with this insight into the inner workings of the ISIS, it can prove to be a more useful companion to you in the future if you ever find yourself in a dire situation where both PFDs have failed for some reason. So this is has been it from my side with some insight into the ISIS, and I will pass it back to Holland for some very exciting previews, actually.
So yeah, I think that's a part a lot of you have been waiting for. Here are some previews of the A380X, which is our A380-800 project. We've been working really hard on the exterior. It's still big work in progress, of course, but we want to show you some really exciting pictures. We also have some FMS previews later after this, and one picture of some interior texturing that we've been working on. Please do keep in mind this is early work and this is work in progress, so this is really not representative of the final product. I say product, but of course it will be free. But we really want to show you some of the progress we've been making over the last few months. So I think we can roll some images now. So here's a preview of our wing with the engines. This is in Microsoft Flight Simulator, by the way. This is not a render. Another shot of the wing. We have a preview of the entire aircraft on the ground. Again, this is in the simulator. And another picture of the aircraft. Now here's some work on the texturing and detailing inside the aircraft. This is in the cockpit where you would store documents and binders. And then now we'll be able to show you some previews of the FMS. I'd like to thank Ashi from Synaptic Simulations for helping out on this and joining our A280 team. It's some really impressive work, and you'll be able to see the loading of some procedures and some FMS pages. We then have a second video showing the loading of airport data. I'll now pass it off back to Sid so we can have the closing word and talk about the Q&A session coming up right now.
Well, thank you, Holland, Boris, Kiwi, and Blueberry for joining us today on the stream. Also, Kevin, who has worked quite a lot on fonts that you guys are going to see in the upcoming days that will be available on the development version. And we'd like to thank all of our viewers for tuning in today in this episode of In the Hangar, episode 7, also our anniversary edition. Right after this, we have another event outside the hangar, which will be held on our Discord. You can find a Discord stage by the same name, which is Outside the Hangar. You can join us on that particular stage and feel free to ask us questions that we'll be discussing shortly on that particular stage on our Discord. Once again, thanks for joining us today in this episode of In the Hangar. Hope to see you guys on the other side, and stay safe, and see you soon with another episode of In the Hangar. See ya.